Now, in this video, we are going to take up one more problem on the projections of solids. The problem read as a pentagonal pyramid, 25 mm sides of base and 50 mm axis length, rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. How to analyze this problem and solve by using the sketch method. So to do that, first we will go for a pentagonal pyramid. So since it is a pentagon, you have 5 sides wherein you have since it is resting on one of its triangular faces. If you want to rest on one of its triangular faces, that triangular face has to be perpendicular to VP. That means the base edge containing the triangular face has to be perpendicular to VP. That is the reason why we have kept the pentagon in the vertical position, so that one of the base edge, which is CD, is perpendicular to VP. Now, once you do that, so here, first what I need to do is, I need to draw an XY line and you will go to mark VP and HP. So once you do that, now you take the triangular face, that is the pentagon. First we are going to draw a vertical line of the base of 25 mm. So then, and you mark that point as C and D. Once you do that, with by using the protractor with respect to CD, with the C as center, you measure an angle of 108 degrees with respect to CD and you draw an inclined line. Similarly, with D as center, again with respect to CD, you measure an angle of 108 degrees, which is the included angle, and then draw this inclined line. Then by using the compass, you measure 25 mm with C as center, cut an arc on this 108 degree line. Similarly, with D as center, cut an arc of 25 mm on 108 degree line, and you mark these 2 points as B and E. With B as center, again you take the radius of 25, draw an arc, and with C as center, with the radius of 25, cut an arc on the previously drawn arc, and you mark that point as A. Then you then join A to B, B to C, C to D, D to E, and E to A with a dot line. Then again, by using the protractor with C as center with respect to CD, you measure an angle of 54 degrees. That is, you are bisecting the angle and you draw an inclined line. Similarly, with D as center, again you measure an angle of 54 degrees with respect to CD, you draw an inclined line. Both these two lines will going to intersect at this point, and you mark that point as O and O1 in bracket. Then join O to C, O to D, O to B, O to A, and O to E with a dot line. Once you do that, so you can see here the OCD is the triangular face and OA is the slant edge. Always you remember, whenever you have a odd number sides, one of the sides or one end will going to be a triangular face and the other side will going to be the slant edge. Now again, from XY line you measure 50 mm and draw a horizontal line in the front view, that is in VP. Then with AS, then by using the then from A you draw a vertical projector to the XY line. Similarly, from B and E to the XY line, and from C and D to the XY line, and from O1 you draw a vertical projector which will going to be taken up to this 50 mm line, and you mark that point as O dash. Then once you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, D and E is away from the observer, therefore D dash and D dash will be in bracket, and O1 dash is in bracket at the base and O dash is without bracket at the top. Then you join between O dash to A, because OA is joined, OB is joined, OC, OD and OE is joined in the top view. Correspondingly, the front view, join between O dash, A dash, that is visible to visible is visible, O dash, B dash, again visible to visible is visible, then O dash, C dash, visible to visible is visible. So you draw 3 lines, a dark line, then A dash to C dash with a dark line, which is the base. Now how do I know that? So here AB, BC, CD, DE and EA all are in true line because A dash, B dash, C dash, D dash, E dash are all are parallel to XY. Therefore, A, B, C, D, E and A are in true line. So what is the length of the true line? Which is 25. Then O dash, A dash is inclined to HP, so OA is in apparent length. OA is parallel to VP, so here O dash, A dash is in true length. But all other lines, that is O dash, B dash, O dash, C dash, O dash, D dash and O dash, E dash will be in apparent length. Now, so this is how you will be able to write the front view and the top view of the initial position. Once you do that, now we go for since it is one of the slant triangular faces are resting on HP. So, which is the slant triangular face? OCD is the slant triangular face which is resting on HP. So, what I need to do is that O dash, A dash, O dash, C dash, D dash is a line because it is the triangular face, and OA is a line because it is the slant edge. So, you have a slant edge because OA is a line what you have here in the top view. So this side is the slant edge and this side is the triangular face. He is telling that one of the slant triangular face has to rest on HP. So you make that triangular face has to rest on XY line in the front view. So how to do that? You take any convenient distance between this line to this line. Then by using the compass, you measure the distance from O dash to C dash. You take any point on the XY line and cut an arc on the XY line. So this point will be C dash, D dash, C dash and D dash is in bracket, and this will be O dash. Then you measure the distance from C dash to A dash by using the compass. With C dash as center, you draw an arc. Then you measure the distance from O dash to A dash with O dash as center, cut on the previously drawn arc, and you mark that point as A dash. Then join A dash to C dash to O dash, and O dash to A dash with a dark line. Then you transfer the distance from C dash to O1 dash by using the compass from the first position front view and take it onto from C dash. You cut an arc on this line. You mark that point as O1 dash in bracket. Similarly, you measure the distance from C dash to B dash, E dash. Then from C dash you cut an arc on this and you mark that point as B dash and E dash in bracket. Then join O dash, B dash and O dash, O1 dash with the axis line, and join between O dash to C dash to A dash and A dash to O dash with a dark line. So this is how you will be able to reproduce the first position, reproduce the second position front view by resting one of the slant triangular face, that is O dash, C dash, D dash on XY line. Then I need to write the top view for this. To do that, draw a vertical projector from C dash and D dash to the top view, and draw a horizontal projector from D and C. Both these two lines will going to intersect at these 2 points. You mark that point as C and you mark this point as D. Then draw a vertical projector from O1 dash to the top view and draw a horizontal projector from O, and these two lines will going to intersect at this point. You mark that point as O1. And then draw a vertical projector from B dash and E dash to the top view and draw a horizontal projector from B and E from the second position, from the first position top view. These two lines will going to intersect at these 2 points. You mark that point as B and you mark this point as E. Similarly, you draw a vertical projector from A dash and draw a horizontal projector from A. Both these two lines will going to intersect at this point. You mark that point as E. Then draw a vertical projector from O dash to the top view and draw a horizontal projector from O. Both these two lines will going to intersect at this point. You mark that point as small o. Then join A to B, B to C, C to D, D to E, E to A with a thin line, and join O to A, O to B, O to C, O to D, O to E with a thin line, and join between O1. Now once you do that, now we have to write the condition of visibility. So what is the first condition? All the exterior edges of the boundaries of the solids are visible. Which are all the edges of the exterior edges of the boundaries of the solid? So you can see CD, DE, EO, OB and CD are all the exterior edges of the boundaries of the solids which are visible. So you dark them. Then once you do that, then the surface which is near to the observer is visible. When you look from the top view, O dash A dash is the slanted which is near to the observer. Therefore, so the surface which is near to the observer is visible. So one should do that from when you look from the top view. A dash, B dash, C dash, D dash and E dash all are near to the observer. Therefore, you mark between A to B with a dark line and A to E with a dark line, D to E to D, D to C and C to B with a dark line. So the entire pentagonal surface in the top view will going to become visible, because when you look from the top view, this entire pentagonal surface is near to the observer, so it becomes visible, so you dark them. Similarly, when you look from the top view, O dash A dash is near to the observer, so OA will also become visible. Or from a point, from A, AB is visible, AE is visible, therefore OA should also be visible. So from a point, if two edges are visible, automatically the third edge is also becomes visible. So OA becomes visible. So you dark them. Then OO1. So here up to OA is visible. So OO1 is coinciding with OA. So always you have to give the priority to the visible edge. So you dark between OA, and from A to O1 you make a axis line. Then the edge or a corner which two visible edges can never cross each other. So which are all the two visible edges which can never cross each other? Only the left out portion is OD and OC. Since OC is crossing the visible edge AB, so two visible edges can never cross each other. Therefore, OC becomes invisible. Similarly, the same explanation for OD, which is crossing the visible edge AE. So you make them the dotted line. Since the entire pentagonal surface is visible, therefore O1 becomes visible. Then he says the axis is inclined to VP. Once the triangular face is inclined to HP, once the triangular face is resting on HP, obviously the axis line will becomes inclined to HP. Therefore, OO1 will going to becomes apparent line. But the inclination is given is the true inclination. Therefore, you have to find the apparent inclination. So to do that, consider any point and draw a horizontal line at any distance from the second position top view. You mark that point as O. By using the protractor with reference to the horizontal line, you measure an angle of 45 degrees and draw an inclined line as shown. Since it is the true inclination, then you take the true length of the axis. Where is the true length of the axis? As the axis O1 is parallel to VP, therefore you are getting the true length. What is the true length of this axis? The true length of the axis will going to be 50 mm, which is shown here. Since OO1 is parallel to VP, therefore you are getting the true length here. Here also OO1 is parallel to VP, therefore you are getting the true length here. This length and this length are equal. Then you measure the distance from O dash to O1 dash from the second position front view with O as center. Cut an arc on that 45 degree line. Then draw a locus. Then you measure the distance from O to O1 from the second position top view with O as center. Cut on the previously drawn arc. The previously drawn the locus line. Then mark that point as O1. Then again with O as center, take the radius of O to this point. From O, you mark that point on that beta inclination line. Then once you get this, from this point you draw a perpendicular on either side. Then you measure the distance from this point to C and also from this point to D, and cut from this to here and also here. You mark that point as C and you mark that point as D. Similarly, you measure the distance from O to this point. From O, you mark that point here on this beta inclination line. Through this point, you draw a perpendicular to this inclined line OO1. Then you measure the distance from this point to B and also from this point to E, both these two lines. So from here, you cut an arc on this side and also cut an arc on this side. So the B, mark this point as B and you mark this point as E. Similarly, you measure the distance from O to A, then transfer it from O onto this beta inclination line. You mark that point as E. Then join A to B, B to C, C to D, D to E, E to A with a dark line. Then dark line between O to A and then O to E and then O to B. Then from O to C you make a dotted line, and from O to D also you make a dotted line. So that what I am doing is I am reproducing the same sketch here on the apparent inclination line, that is the beta inclination line. Once you do that, now I need to write the top front view and draw a vertical projector from O and also from C and D to the XY line, because O dash, C dash, D dash is on XY line. All these three lines will going to intersect at this point and this point and this point. You mark those 3 points as O dash, D dash and C dash. Similarly, draw a vertical projector from A and draw a horizontal projector from A dash. Both these two lines will going to intersect at this point. You mark that point as A dash. And draw a horizontal projector from B dash and A dash, and draw a vertical projector from both B and E. These two lines will going to intersect at this point. You mark that point as E dash, and similarly this as B dash. And draw a horizontal projector from O1 dash and draw a vertical projector from O1. These two lines will going to intersect at this point. You mark that point as O1 dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to A dash with a thin line. Then join between O dash to A dash, O dash to B dash, O dash to A dash and O dash O1 dash with the axis line. And of course already O dash, C dash, D dash are joined. Then apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. That means O dash to C dash, C dash to B dash, B dash to A dash to E dash and E dash to O dash with a dot line, because these lines will going to form the exterior edges of the boundaries of the solid. Then the surface near to the observer is visible. As you look from the front view, see this entire surface of ABCD is near to the observer. So already A dash is visible. You dark between E dash and D dash. So the entire pentagonal surface becomes visible. Then two visible edges can never cross each other. Apply that rule here, because as E dash D dash is visible, therefore A dash and O dash are crossing the visible edge, therefore O dash A dash will be invisible. Similarly, B dash is crossing the visible edge of D dash and D dash, therefore B dash O dash will be invisible. Since the entire surface ABCD is visible, O1 dash is on that surface, therefore O1 dash will be without bracket. Then join between O dash and O1 dash with the axis line. So this is how you will be able to complete the third position front view in the manually by this. How do I know that my problem is right? You can see that the pentagonal surface of 25 mm is on height 50 mm is resting on one of the triangular faces. Since the axis is inclined to HP, therefore you are getting the apparent length, and the inclination given is the true inclination. So therefore I need to find out the apparent inclination here. So once we found out that apparent inclination, on that apparent inclination line we are reproducing the same sketch here, and then you can see even in the final position the triangular face O dash, D dash and C dash are resting on HP. So this is how you will be able to analyze and solve the problem on the pentagonal pyramid, which is resting on one of its triangular faces on HP. Always do remember that whenever in a pentagonal, whenever in the odd number size is given, whether it is resting on triangular face or whether it is resting on the slanted, always you remember that make that vertical edge perpendicular to VP, because one side you are going to have a triangular faces and the other side, that opposite side, will be a slanted always. This will be applicable only to the odd number size like a pentagonal surface or a pentagonal pyramid. So this is how you will be able to analyze and solve the problem on projections of solids. Thank you.